In question 2 of this series, we'll continue balancing chemical equations, and we ended off with question 2. We're asked to write a balanced chemical equation for the reaction between solid silicon dioxide and solid carbon that produces solid silicon monocarbide and carbon monoxide gas. Let's start by writing out the chemical formulas for each of these compounds. Starting with silicon dioxide, we have SiO2, and that is a solid. So I'll write down S, plus solid carbon, also an S, and this produces solid silicon monocarbide, which is SiC, mono means only one atom within this molecule, and carbon monoxide, a poisonous gas, plus CO, and that's a G, and this right here should be an S. Just as in question 1, we want to write down the atoms for the left side, and the same atoms will be present on the right side. So we'll make a little chart. I'll write down Si, O, and C. Similarly, let's count how many silicone atoms there are on the left side. We have only one because there's no subscript present, so we assume it's 1. Oxygen is 2 because of this 2, and carbon is 1. Silicone on the right side is 1 oxygen, and 1 carbon. This is not so bad. All we have to do is balance the oxygens, and for that I will put a 2 in front of carbon monoxide. This will change the amount of carbons on the right side, will make it 2, but it will also change the oxygens. So now the oxygens are balanced, the silicone atoms are balanced, but the carbons are not. All we do is place a 2 in front of this atom, and now we have a perfectly balanced chemical equation. Let's move on to question 3. In question 3, they ask us to write a balanced equation for the combustion of gaseous butane, which has the chemical formula C4H10, a fuel used in portable stoves and grills, in which it combines with gaseous oxygen to form gaseous carbon dioxide and gaseous water. I'll start off by writing out butane's formula. We have C4H10, and this combines with oxygen to form carbon dioxide gas and water vapor, H2O. So we have a typical combustion reaction here. Just like in the previous question, let's write down the atoms on the left side, and the same will be present on the right side. We have C for carbon, H and O, C, H, and O. We have 4 carbons, 10 hydrogens, and 2 oxygens. And on the right side we have 1 carbon, 3 oxygens, and 2 hydrogens. I would say that this question is a little more difficult than questions 1 and 2 because we have 2 compounds both containing oxygen. Notice that we have an oxygen here and an oxygen here. So it makes it a little more complicated when it comes to balancing, although it's still doable. I'm going to start by balancing out the carbons, and I can do that by putting a 4 in front of this molecule. If I do that, the amount of carbons goes from 1 to 4, and the amount of oxygens goes from 3 to 9. Now let's make sure you understand why. 4 times 2 is 8, plus 1 gives you 9. The carbons are balanced, the oxygens are not, neither are the hydrogens. So my next step will be to place a 5 in front of this water. If I place a 5 in front of that water, the amount of hydrogens jumps to 10, because 5 times 2 is 10. And 5 times 1 is 5, plus the 8 that was there gives us a total of 13. The carbons and the hydrogens are balanced, but the oxygen on the left side is not. Now most likely your teacher taught you never to use numbers with decimals as coefficients when balancing, although sometimes it's a necessary evil when balancing combustion reactions. Let me show you what I mean. What can I multiply 2 to get to 13? And it can be any decimal number. Well, I know 2 times 6 is 12, and I know 2 times 7 is 14. So in the middle, between 6 and 7, will be 6.5. So I'll write down 6.5, and this will give me 13. But of course, you can't have 6.5 oxygen molecules. So you see why your teacher likely forbids you from using decimal numbers. But a little bit of math goes a long way here. 6.5 is the same thing as saying 6.5. And this is a mixed fraction. We all know what mixed fractions are. It's when you have a whole number with a fraction beside it. And to go from a mixed fraction to an improper fraction, we multiply this 2 with this 6, which gives us 12, plus 1, that gives me 13 over 2. This means that I have to multiply every one of these compounds by what's at the bottom here, this 2. So I have to multiply this by 2. Multiplying 6.5 by 2 gives me 13. Multiplying 4 by 2 gives me 8. And multiplying 5 by 2 gives me 10. Now that's, of course, going to change each of these. So let's recount. We have 2 times 4 is 8. 2 times 10 is 20. And 13 times 2 is 26. On the right side, we have 8 times 1 carbon, that's 8. 8 times 2 is 16. And 10 times 1 is 10, that's 26. And 10 times 2 is 20. Notice that all of these are balanced. Had you not chosen 6.5 in front of the oxygen, you would continue to balance left and right until you finally reach these outcomes. You don't need to use 6.5. You could have just used different combinations until you reached this answer. So by choosing 6.5, I sort of made it easier for myself to figure this one out. If you want the answer to question 4, make sure you watch part 3 of this video, and we'll hope to see you soon.